let's talk about the cross product in a component form. Now, it's very intuitive to think of the cross product as torque, and we apply to a simple torque problem where you're given the length of the wrench along with a force and angle the force is being applied to the wrench. But suppose we simply need the cross product of two vectors that are presented in component form. So consider these two vectors, vector A and the components, vector B and the components. Now we can find A cross B by applying the vector distributive laws together with the results that we looked at when we considered the idea of I cross J and J cross I. However, this is really pretty messy. So rather, let's take a look at the idea of using a 3x3 matrix to find a cross product. So let's start off with the idea of a determinant of order 2. This is a 2x2 matrix. So all a determinant is a cross product. So if I take A and multiply by D, multiply these guys together, then multiply these guys together, I get A times D, and I subtract these two, which is C times B. So the example of numbers, if I want to find the determinant of this 2x2 matrix, I would take 3, multiply it by 7, and subtract 2 multiplied by 5. And obviously that's a number. The actual value I don't really care about at this point. I just want to think about the algorithm to find a determinant with a 2x2 matrix. So now let's go to the idea of a determinant of order 3 for a 3x3 matrix. And this is the basic idea behind the way this is going to work. So first I'm going to key off of A1. So I will take whatever the value is in A1, so I'll take this, and I will multiply it by, what I'm going to do is I'm going to pretend like this does not exist, but this creates a 2x2 matrix. So I will find the 2x2 determinant of this little submatrix, so to speak, which would give me B2 multiplied by C3 minus C2 multiplied by B3. So now, let me grab an eraser, get rid of this. Now I'm going to go to the next component of the determinant of order 3, and I'm going to key off of A2. So I will have a 2x2 matrix made up of this guy and this guy. I'm going to pretend like this isn't here. So I'm going to have A2 multiplied by B1 times C3 minus C1 times B3. And then, you notice here I didn't put anything right here. We're going to come back to this in just a second. And then, let me grab my eraser again and get rid of all that. I'm going to key off the value in A3, which means I'm going to pretend like this doesn't exist, and I have this new 2x2 matrix. So I'll have A3 multiplied by B1 times C2. Whoops, that's supposed to be a B. See, B1 times C2 minus C1 times B2. Now I have three components here, and the pattern is plus, minus, plus. So this is going to be plus, which means it doesn't really matter. If this turns out to be negative, then it's a negative. This is a negative, and then this is a plus. So it's this component minus this component plus this component. Obviously, all these signs will change depending on the sign of A1, A2, and A3. Now I realize that can kind of seem like a convoluted mess, but let's go through a couple more examples because this is the way we would really use it. So I'm going to have IJK, then A1, A2, A3, B1, B2, B3 when I find the cross products between these two vectors. And this is the form that we typically find. This is what we thought of earlier as A1, A2, A3. We just shifted over, and I'm using I, J, and K as my first row. So to start off with, I would key on I, which means get rid of this, and think of this matrix right here. So I'm going to write this time slightly different. I'm going to say A2 times B3 minus B2 times A3 I, before, based on this example, see this is my I would have put it out here, but I want to go back to the vector form because the cross product gives us a vector, so I'm going to put it in the proper component form for a vector, minus, now I will erase this, and then do the next component, which would be, I'm going to key on J, so I'll get rid of this, A1 times B3 minus B1 times A3, J, plus, now I'll key on K, which means pretend like this doesn't exist and work with these guys right here. That'll be A1 B2 minus B1 A2 K. And notice this is a vector in component form. So hopefully you'll see when I replace these with actual values from a vector that's not written generically like this, I will end up with numerical values here, here, and here, and I will have a vector in my typical component form using the IJK basis vectors.